Okay, this is lesson 5-3, and the topic here is reflection part 2. Now, in the last lesson we learned about reflections, and the line that we reflected over was either the x-axis or the y-axis. Now in this lesson we're going to learn how to reflect over different lines of reflection. It's not always going to be the x-axis or the y-axis this time. So these are examples of the type of lines that we're going to have to reflect over. So like for example, the line y equals 3. Okay, so let's see if we can figure out where that line is. Okay, so first of all you want to locate 3 on the y-axis. So we go up 1, 2, 3. There's 3 on the y-axis. The line y equals 3 is a horizontal line that goes through 3 on the y-axis, right? So any line that's y equals, it's going to be a horizontal line. Y equals -1, locate -1 on the y-axis, draw a horizontal line through it. That would be the line y equals -1. Y equals 2, go up 2, draw a horizontal line through it. That's the line y equals 2, right? Now, x equals, where would x equal 4 be? So let's say x equal 4 is the line of reflection. We have to locate it. Well, go 4 on the x-axis, 1, 2, 3, and 4. And the line x equals 4 is a vertical line that goes right through 4 on the x-axis. Where's the line x equals -2? Go to -2 on the x, and then draw a vertical line through it. Whereas x equals 1, go over 1, draw a line through it. So just remember, y equals is going to be a horizontal line through that number on the y-axis, and x equals is going to be a vertical line through that number on the x-axis. So the first thing we have to do is be able to locate where these lines are, because these are the type of lines that are going to be our line of reflection this time, not necessarily the x or y axis every time. Alright, so now that we're aware of how to find these lines, let's go through and take a look at some of the problems that we're going to be dealing with. Alright, so in this first problem, here's my triangle. All 3 of the points are there, the vertices, and they are labeled with the coordinates. Alright, and so first of all, they're telling me that we're going to do a reflection with the line x equals 3. And I have to find all the prime points. Okay, so before I proceed any further, I need to figure out where the line x equals 3 is. We'll go over 1, 2, 3 on the x-axis, and then draw your vertical line through it, right? So there is the line x equals 3. So that's the line that I'm reflecting through. That's the line that I'm flipping across, right? So, with A, the first thing that we need to do is we need to see how far A is away from the line of reflection, meaning this line. Okay, we need to see how far A is away from this line. So when we count it, there's 1, 2, 3, 4, and 5. So A is 5 away. So A prime is going to be 5 away in the opposite direction. 1, 2, 3, 4, and 5. Alright, so there would be the point for A prime. Alright, there is the point for A prime. Alright, and notice it's the same distance away from the line of reflection, which is here. What are the coordinates? Let's count it and see. Now remember, when you're counting coordinates, you got to count from 0, 0. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. And up by 1, 2, 3, 4. So that means 8, 4. That is going to be the coordinates for A prime. Alright, so what about B prime? So B is here. How far away is it from the line of reflection? 1, 2. So then my B prime is going to be 1, 2 in the opposite direction. Remember, however far away the pre-image is, that's how far away the image or the reflected point is going to be. There's B prime. We can get its coordinate now as well. Over 1, 2, 3, 4, 5, up 1, 2, 3, 5, 3 is B prime. Alright? And now for the last one, C prime. How far is C away from the line of reflection? 1, 2, 3, and 4. So we go 1, 2, 3, and 4. And C prime is here. We can count the coordinates now. 1, 2, 3, 4, 5, 6, 7, and up by 1. 7 and up by 1. 7, 1. Alright, 7, 1. Okay, so there you go. Alright. Now, once you get it reflected, then you can go ahead and complete the triangle. Draw the rest of the triangle out there. Okay? And then so here's the triangle before the reflection. Here's the triangle after the reflection. Now, just like in the last few sections, we are going to have to write the rule for this. And so when we go and try to figure out, okay, so A, for example, is at -2, 4. And we're going to have to try to figure out how to get that to 8, 4. Now, the y-coordinate has stayed the same, 4 and 4. Is that the same all the way down the line? 3, 3, 1, 1. So for this particular reflection through the line x equals 3, then it's pretty safe to say that the y value is not changing. But what about the x value? I'm going from -2 to 8, right? And you might say, well, that looks like plus 10, okay? But what about here, though? All right, 1 plus 10 is 11, not 5, so it doesn't work that way for that one. So not just adding a certain number is not going to be it. Okay, now, if we had a lot of time to just kind of guess and check and explore, I would let you do that. But in the interest of time, I'm going to have to go ahead and kind of give you a little bit of guidance on how to find the rule. All right? Now, when we go through and do this and find the rule, okay, what we're looking at first is changing the sign of this value, right? Changing the sign of the value is what we're looking at doing here first. And so when it's off of the axis, okay, we're going to change the sign. That's the reflection, right? Now, in addition to changing the sign, and that's kind of what happened too with the reflection when it was right in the axis. So we are going to change the sign, so it's going to be -x, all right? Now, there's still an adjustment that we have to make, because -2 doesn't just go to +2, right? It goes to +8. So what's the adjustment that we have to make here? Well, the adjustment that we have to make would be this, all right? Whatever this number is, right? Whatever the number is here that the line of reflection is equal to in the equation for that line, you want to take this value, all right, and you want to do it times 2. All right, so what's 3 times 2 is 6. So that means I'm going to add +6 to my -x. All right, and let's just verify that that does work. So -2 changes to +2. +2 plus 6 is 8. All right, does it work for B? 1 changes to -1, and -1 plus 6 is 5. All right. Let's see what else. Here we've got -1. -1 changes sign to +1, and +1 plus 6 is 7. All right. So again, the rule when you have a reflection with a line x equals something, first of all, change the sign of the x in the rule, and then multiply this number times 2, and then add it back to it. All right. Let's see. And also, what did we say about the y-coordinate? It did not change. 4, 4, 3, 3, 1, 1. So it's -x plus 6, comma, y is how you would finish it, because the y number does not change at all. Okay? So again, change the sign, and then add this number times 2. All right, so why is it like this? Well, remember, you flip the sign just for a reflection. Even when it was a reflection in the y-axis, you just change the sign of that coordinate, that x-coordinate. But now, since we're off center, right, since we're off the y-axis, then first of all, the amount that it's moving off is 3. You have to make that distance up. But remember, when you flip it, the reflection is also that much away, so you have to double that distance, in other words, is what we're saying. That's thus the times 2 here. All right? So that's just kind of a rough explanation of why it works the way it does. Okay? Let's try another one. Okay, suppose now I want a reflection with the line y equals -2. Well, where is y equals -2? It'll be down 1, 2 spaces, and then there's a horizontal line right here going through it. All right, so there is the line at y equals -2. That's the line that we're flipping over for this particular one. So I need to find a prime. So we'll start with that. So a is 1, 2. Remember, we're not going to the x-axis. We're going all the way to the line y equals -2. So it's 1, 2, 3, and 4. So we'll go 1, 2, 3, and 4. All right. Okay. And that's going to be A prime. Well, what are the coordinates? Well, from 0, 0, it's -2 and down by 1, 2, 3, 4, 5, and 6. So -2, -6 is the coordinate for A prime. All right. Now for B prime, we'll use the same procedure. It's 1, 2, 3, 4. So we'll go 1, 2, 3, and 4 down. And there's my B prime. I do want the coordinates for it, and so it's going to be 1, 2, 3, and 4. And so, wait a minute, let me count that again. 1, 2, 3 is the right count. So it's over by 3 and down by 1, 2, 3, 4, 5, and 6. Over 3, down 6. So that would be 3, -6. 3, -6. Okay. The next one for C prime, we're going to take C and go 1, 2, and then now it hits the line of reflection, so we go 1 and 2. Okay, so there is how C flips. There's C prime. Coordinates are going to be 1, 0. 1, 0 is the correct coordinate for C prime. Okay. Now remember, when you're done, you can go ahead and draw in the new triangle just so you can kind of see how it flips. Alright, so now that we've got it drawn in, you can see how it flips over this line. And remember, the line of reflection is going through the triangle, so just like when we addressed that in the last lesson, that's fine. It just kind of flips over itself. Alright, so this flips to here, this flips to here, and this actually comes up and flips to here. And notice how the new triangle is flipped when it's drawn, the prime triangle. Alright? Now, how are we going to write the rule for this? Well, first of all, let's take a look at the x coordinates. So -2, -2, 3, 3, and 1, 1. So actually, the x coordinate does not change. It's going to stay the same. And so we just kind of write that back in. As an x, it'll stay the same. Now, here is where we're going to have to make the adjustment. We got to make the adjustment in the y coordinate. So the y coordinate goes from 2 to -6, from 2 to -6, and from -4 to 0. So how are we going to account for that? Well, remember what we said. With a reflection, the first thing you got to do is change the sign. So it's going to be -y. So it's going to change from +y to -y. So whatever the y is, change the sign. Now, after we change the sign, we need to add it by this times 2. So what's -2 times 2? Well, -2 times 2 is -4. So we would add a -4, or that's just the same thing as saying subtract by 4. Alright? So don't forget to take that number in the equation of the line and multiply it times 2. So change the sign of the y, take this number, do it times 2, and put it on behind it. Add it to the back of it. In this case, -2 times 2 is a -4, so you'll just write -4. So now that we have used our rule for writing the rule, let's double check and make sure that it works. What if I plug in a -2? What if -2 is my y coordinate? -2 would change to +2 with that negative, and +2 minus 4 is going to be, let's see. So when I put that in there for the A, and then using that coordinate, then I plug that back in, so that would be 2, right? That'd be +2. Let me try that again. So 2 would change to -2, right? And then -2 minus 4 is -6. So that one works out. Same thing here. It'd be the same thing. -2 minus 4 is -6. And what about here? -4 would change to +4. Minus 4 is 0. And then so all three of them actually work out. All right? And that will conclude the lesson.